Now let's see the next scheduling algorithm. Okay, the next scheduling algorithm is priority based scheduling algorithm. Okay, see, actually we have seen lot of priority based scheduling algorithms, right? We have seen SJF, SRTF, LJF, LRTF. All these are priority based scheduling algorithms. Why? Because we give higher priority to processes with shortest burst times over here. Okay, whereas here we give priority to processes with the largest burst times, right? So they are clearly priority based scheduling algorithms. Now instead of taking the burst times, what they have told is they have given one more thing, right? See, they have given process number, arrival time, burst time. Along with that, they have given a priority number to every process. Okay, so what do they really mean here is they are saying that the process with the priority 12 should be given the highest priority. What does it mean is, see, among these numbers 12 is the largest number, right? So by this what they really mean is, in case if the priority number is higher, you give the highest priority to those processes. For example, here we have, let us assume these two processes 10 and 9, right? Among these two processes, the higher priority will be given to this process, which is P4, right? Because 10 is greater than 9. Okay, that is what they have given. See, actually there is no such rule that in case if the priority number is greater, they should be given higher priority. For example, in case if they would have given, instead of 12 being the highest, in case if they would have given that 6 as highest, it means that in case if the priority number is lesser, you give the highest priority. Okay, so it really, there is no such rule, but since in the problem they have clearly mentioned that in case if the process is having a higher priority number, give the highest priority. Okay, since they have mentioned it, we are taking it. Fine. Now let's solve this problem. It is actually very simple. Okay, we have solved a lot of problems related to SJF, SRTF and all this. It is almost similar to that. Instead of burst time, we'll be seeing the priority number. Okay, anyway, let's solve this. See, there are two versions of priority based scheduling algorithms. Okay, we have both preemptive as well as non-preemptive. Okay, now let's first solve non-preemptive and then we'll solve preemptive. Okay, fine. Now we will draw the Gantt. Let's draw the Gantt chart. We will start with time unit 0. Now at time unit 0, the only process which has arrived to the RAM is P1, right? Apart from P1, no other process has come. So we will start with P1 and we need to complete P1 because it's a non-preemptive scheduling algorithm. So we will complete P1 till 8. Okay, so P1 is done. Now until from 0 to 8, every process has come to the RAM, right? P2, P3, P4, P5 and P6, all of them have come to the RAM. So among these processes, we need to pick the process with the highest priority number, and it is very clear that P3 has the highest priority, right? So P3 will be scheduled and P3 will run for 4 time units, so it will go till 12. So P1 is done, P3 is also done. Now the next highest priority should be given to process P6, right? So P6 will start and then it will continue till time unit 15. Okay, fine. So P6 is also done. The next highest priority should be given to P4, right? Because 10 is greater than 9, 6 and 8. So P4 should be given the highest priority and P4 will continue till 17. Okay, so P4 is also done. Now among these two processes, the process with the highest priority is P5 because 9 is greater than 8. Fine. So P5 will be scheduled and it will continue till 27. Okay, it will continue till 27. Fine. Now the next highest priority, now the only process which is remaining is P2 and P2 will continue. Okay, P2 will continue till 33, right? P2 has a burst time of 6, so from 27 to 33. Fine, this is what we mean by non-preemptive priority based scheduling algorithm. Actually it is very simple, right? We were seeing the burst times before, rather here we are seeing the priority number. Okay, they have explicitly mentioned that you give higher priority to this process. Okay, that's what they mean by this. Now instead, in case if they would have given that this as highest, it means that process process with the least priority number should be given the highest priority. Okay, there is no definitive rule that in case if the priority number is higher you need to give the higher priority, or if the priority number is lesser you need to give the higher priority. It really depends on the problem itself. Okay, in the problem they might have to mention it, and here they have given that in case the priority number is lesser, you give the highest priority. Okay, so depending on the problem we might have to solve. Fine. So that's it, we have solved the problem. Now we shall compute the completion time, turnaround time, arrival time and all this. Okay, it is very straightforward, but anyway let's solve it one more time. Completion time of process P1 is, this is P1, this is P2, P3, P4, P5, and we also have P6, right? 1 2 3 4 5 6. Fine. Now P1 completes at time unit 8, P2 completes at time unit 33, P3 completes at time unit 12, P4 completes at time unit 17, P5 completes at time unit 27, P6 completes at time unit 15. Okay. Now we shall compute the turnaround time, and we know that turnaround time equal to completion time minus arrival time. So 8 minus 0 is 8, 33 minus 1 is 32, 12 minus 2 is 10, okay, 17 minus 3 is 14, 27 minus 4 is 23, and 15 minus 6 is 9. Okay, turnaround time. Then we can compute the waiting time. And you know, as you all know, since and here also we assume that IO time of all the processes equal to 0. Okay, and so waiting time equal to turnaround time minus burst time. So 8 minus 8 is 0, 32 minus 6 is 26, then 10 minus 4 is 6, 14 minus 2 is 12, 23 minus 10 is 13, 9 minus 3 is 6. Okay, now we can calculate the average waiting time, right?